Good evening, participants. Team RFI, am I audible? Am I audible now? Team RFI? Participants, are you able to hear me? Okay, thank you, ma'am. Today's expert, Dr. Samir Dubey, sir, will be going to join us within few minutes. After that, we will start the session. Anyone from RFI, please contact me. Participants, there is a bit of a delay in our session. Actually, I'm not able to connect with our expert. Sameer sir, are you there? Dr. Sameer Dubey sir, are you there? Dr. Sameer Dubey sir, are you able to hear me? Okay, okay. Yes, sir. Welcome, sir. First of all, I apologize to every participant for the delay in our session. Now, Sameer sir has joined us. So, once again, good evening to all esteemed members of Team Research Foundation of India, distinguished guest speaker Dr. Sameer Dubey sir, and dear participants. A very warm welcome to the 10 days training and faculty development program on advanced tools and techniques for research methodology. Today marks the fifth day of the FDP, focusing on the theme application of SPSS for data analysis. This program is organized by the Esteemed Research Foundation of India, RFI-CARE, and DPIT, and is sponsored by JHRF, the Academic Research Guide Association, and Edu Academic Inc. Before we proceed, allow me to introduce today's schedule expert, Dr. Sameer sir. He holds postgraduate degree in commerce and management from Devi Ahilya Vishwavidyalaya, Indore. He has 20 years of academic experience and 4 years of industry experience, having worked with Vardhaman Polytechs Limited, Ludhiana, Indore Institute of Management and Research, IPS Academy, and Acropolis Institute, Indore. Currently, he is with the Prestige Institute of Management and Research, Indore. He has more than 20 national and international publications in research journals and conference proceedings. He has a case study published by the European Case Clearing House and has co-authored a book titled Banking Law and Practice in India. He is a member of the Madhya Pradesh Economic Association and the Research Foundation of India. Additionally, he has been training faculties in managing virtual classes and preparing video lectures. His research interests include financial institutions and services, financial policies and behavioral finance, banking, multi-faculty collaborative research, and research methodology. So with this brief overview of Dr. Dubey's impressive profile, I would like to invite him to share his insights on the theme of today's session. Over to you, sir. Yes, sir, you are audible.
There is no voice coming, ma'am.
Sameer, sir, I think there is some network issue. Sameer, sir, Sameer, sir, are you there? Sameer, sir, you are not audible. Are you there? Sameer sir? Yes, sir, now you are audible. Please continue. Yes, sir. Sameer sir?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. Okay. Thank you so much. So the window, as of now, you are seeing this window has two different options on the left bottom side. You can see, as if you can see, there are two different options: data view and variable. So what we need to do is we need to start off with just a second. Rather than sharing a window, let me share the complete screen with you. That would be easier for you people to understand how it looks like actually. Entire screen. Okay. Now you people can see the entire screen. This is how you will find how SPSS looks like whenever you start it. Okay. So this is the startup pop-up. Here you can see the files, name of the files which I have been already using. So the name of files will be there for quick access of the file. And then since this SPSS uses a little some functions of R as well. So that's why these kind of creatives and all these things are there. What you need to do is just have to cancel it. If you want to use a file which you were earlier using as well, you can select it from the left hand side pane. But otherwise, you can only have an OK or you can cancel. So I simply cancelled it. Now you can see here it is SPSS. On the very top pane you will see untitled one, dataset, IBM SPSS statistics, then file, edit, view, data, transform, analyze options, and all these kind of things. And here you will find that some sort of data functions are already there. These are the functions which we are going to perform on data. Now it looks like as if it is an Excel sheet. Okay, I believe it is like visible to everyone. It looks like as if it is an Excel sheet. So it is having rows and columns. As of now, I'm in the data view. Here you can enter the data. Okay, but what data you need to enter? We shall be entering the values of our variables, and from where the variables will come now. So you can once again see on the left bottom side. I'm showing you here. There are two different views. The first one is data view, and the second one is variable view. So let us go to variable view. Here, what happens is you need to define the variables. Now, what kind of variables would be there? So the variables would be the very same which you have collected with the help of a questionnaire. How it looks like, how that variable looks like. Let me show you how it looks like actually. Okay, so let me show you how our Excel file will look like. Okay, now everybody can see the Excel file. I believe you people would be able to
Yes,
see the
sir.
Excel sheet right now. Okay,
Yes.
so this is how our file looks like. I believe this is familiar to you as well. On the very first, like I have already prepared a little bit, so that's why I am hiding the top 6 rows of the very same. Otherwise, definitely this will be the first row. So what happens is this is our actual file. What you need to do is this is our question. This is here from where it is starting. The very first one is patient ID. The second one is age in years, then patient's gender, then patient's ethnicity, then question number 1, question number 2, 3, 4, 5, and once again height, weight, neck circle, then waist, hip, then this is BP, like higher and lower BP. So this is the data that have been collected. I believe you are familiar with this. All of us used to collect data in the very same fashion. Only difference is like this is some sort of data which is related to some medical research. Medical research in the sense research, but that is some sort of some having hospital as a center. So this is the reason why we have collected this kind of data. Otherwise, you will be having data as per your questionnaire. So I believe everybody has seen this. Now what happens is we have to transfer this data to SPSS. How we have to transfer this data is there are two different options. First one is you prepare an Excel first. Second option is you can prepare the data, you can prepare the SPSS and you can directly input the data in SPSS. What we are doing right now is since we already have this Excel sheet and you people would also be having this Excel sheet. So we shall be transforming data from this Excel sheet to the SPSS. How we should do it, that I am telling you. So the very first thing that you need to do is you just need to identify which columns which variables you have to select. Here you can see in the rows, you will find in the very first column, you will see it is written patient ID. And then we are having patient ID 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or so. So what happens? Some of the IDs are missing and some of them are repeated as well. It's okay. So, but it should be different. So it is like there are 20, this is the data about 20 different patients. What we need to do is, this is the number of rows, number of respondents, and the columns are variables. This is how you have to prepare your data, because it resembles very same to the SPSS. What you have to do is, you have two different options. Very first option I'm telling you is selecting all the data. So here I'm selecting all the data. I believe you are comfortable with selecting all the data. I believe you people are. In Excel, we have to.
Yes, sir.
So this is how we have selected this data. Now I am pressing Control and C. So what happens after Control and C? This will copy the data. Or you can alternatively, what you can have, you can right click. So I have right clicked as well, and I will copy the data. Now this data has already been selected. Some clipboard error, it's okay. So this is how we have selected the data. We have captured the data. What we need to do now, we should open SPSS over here. Go to data view. Make sure that your data view is open, not variable view. If you paste it in the variable view, your data will be lost. So what you need to do, open the data view. Put your cursor on the first row, first column, the first cell, and then Control and V. Alternatively, right click and paste. So that's what we can do. So this is, our data is already here. And here it is. Control V. Now you can see the data has been pasted. I just have copied data from there and pasted it over there. Is it clear to everyone? Now what we have to do, we have to put the data, because otherwise it will only be a number. And whatever statistical or SPSS operations you will perform on this will result into nothing. What we need to do is, we need to code it. We need to name it. What exactly is this data is. So let us go to the variable view. Okay. Now what happens in the variable view? Here you can see 15 different variables are there. We have to name them. Let us go to our Excel sheet and now name them. The very first one is age in years. So here it is. Write down what happens. I believe that you people can see this variable view. Now what are there in variable view? The first one is name of the variable. The second one is type of the variable. Third one is the width, how much characters this variable is taking. However, 8 is default and 2 in the decimals is once again a default. However, you can reduce the very same as well. If you keep this 2 in the decimals, all the variables will have 0.00. Here it is. Here you can see. You can see that this is 0.00. Although there are certain variables where you do not have to put even 0.00 or so, but still it is there. Why it is so? Because we have selected as if it should have that by default. So in the variable view, since we have selected decimals, hence the decimal is coming. Otherwise, what you can do is, you can remove decimals for selected variables. How selected variables? This should be the variable number 1. Age in years will be variable number 1. Patient's gender would be variable number 2, 3, 4, 5. So here you can see that in this variable, this is second variable, patient's gender. We will have male and female, only 1 and 2. We do not need any decimal over here. So what we can do is, in the second one, what you can do is, you can reduce it to 0. Here it is. Now when you will go to data view, you will find that variable 2 is not having any decimal values. I believe you can see this. You can observe the change, no? So it is here. Now how to, this is width, this is decimals. Now the label, what exactly the variable says. Because what happens in the name variable, in the name field, what you can do is, you cannot use spaces. So the only thing which is permissible to use in the name field is that you can use underscore, not more than that. So the very first one is, the very first data what we are having is age in years. So let us have age space in space years. Now, when I confirm it by clicking enter, what happens? It has shown an error. I believe you can see this error. Variable name contains an illegal character, and space was that illegal character. So I have clicked OK. Now let me once again make it age only, and then here I have to write down age of the patient. So here it will accept whatever you write, whatever you type, it will accept over in the label field, but in the name field it will not be accepted. Then it is having certain values. Since our values of the age are not very much defined or predefined, hence we will keep it as it is. Missing values, if you are having some values missing, let us check whether this age in years is having some values missing. None of the value is missing. Okay, so we have left it, we have leave it. Otherwise you will find that in some of the data some values are missing. Here you can find some values are missing. So how we shall be using these values? In weight you can find some values are missing. Okay, so some people are there who do not write anything. We get these kind of questionnaires as well. Some people do not fill proper questionnaire properly. How to use that we shall be discussing later on. So now it is label, then values, then missing value, then columns. How many columns we shall be using? Since it is the width is by default the width is 8, and we shall be using 8 columns for this. Alternatively, you can reduce it as well. Then it is alignment. It should be right aligned or left aligned. By default, all the numbers are right aligned, all the strings are left aligned. Then the measures are known, unknown. So let it be unknown. And the role of the data. What kind of data it should be? Like measure, it should be whether it is a scale variable or ordinal variable or nominal variable. So age is nothing like it. We can call it, we can use it as if it is an ordinal variable. So we shall be using it as an ordinal variable. Role, whether it is an input variable or an output variable or a target variable or a partition variable. So you can keep it input as well. As of now, we do not have any other variable. So all these variables are input variables only. No, none of them is an output variable. In higher studies, we shall have some output variables as well. So the first one is age. Second one is, let me see, gender. So second one, let me write it down. Gender, numeric age 0, gender of the patient. And here you will find that we have two different values, one for male and two for female. So what you have to do is you have to go to values. Whenever you click on values, you will find, just a second. Whenever you click on values, you will find that it gets activated by clicking on this small square. So when I click on this small square, you will find the values. What we have to write down? The numerical value 1, for which we have 1. We have assigned 1 to males. So here it is male. Okay, then come to add. Here it is added. Now let us come once again to 2, and 2 is given to female. Here it is female. And now you just have to click OK. And you will find that the data in data view has changed. Here it is. I believe everybody can see that the data has already changed. In some cases, like in this one case, here 3 has been written. It means that it is a wrong entry. I do not know whether it is a correct entry or not. Why so? Because in our Excel sheet, it should either be male or female, nothing else. So you have to identify whether this is a male or female. Okay, this you have to identify. Now let us come back to SPSS. The third variable, let me once again check from the Excel. The third variable is patient's ethnicity. Malay, Chinese, Indian, others. Ethnicity, or you can say country from where the, or when we are conducting the research in here only, you can write down the names of the cities, you can write down the names of states, you can write down whatever you want to write down from wherever you have collected the data. So this is whether It depends once again upon the research you are doing, whether you are doing a research in which different ethnicities are required or not, whether a person from different city, different state, different backgrounds. Religious, it could be a religious background as well. It can be religious background, it can be your language, it can be based on languages, it can be based on religion, it can be based on each and everything, anything. So this is patient's ethnicity. Then let me show you how this is our first, second, third, and fourth variable. Let us come to fourth variable now, because it is the Likert scale variable which we were using, which we have to use. So here it is. Let us come to variable number 4. 1, 2, 3, 4. So here it is variable number 4. Let us go to variable view, write down variable number 4, and this is question number 1. Now we do not know what the question was. We do not, as of now, we do not know what the question was. Okay, so what you can do is write down question number 1. Numeric 8, 2, let it be by default. If it is already set, let us do not change it a lot. Now let us come to label. And label also, you need to know what exactly the question was. Actually, this was some sort of patient's some sort of like patient's dietary or patient's satisfaction survey, or that kind of thing it should have been. So that's why here what you need to do is you need to write down the complete sentence. Okay. So here we shall be writing the whole sentence depending upon what was there in the questionnaire. This is what you have to do. Okay. So this is how what we have done is you have to make the conditions. I believe you people can see this. This is how you have to define the data. This is over here. I believe you can see this. The very first column is on variables, the second one is on description.
Yes, sir, we can.
Should be there. And the third one is your conditions and labeling. So these values you have to put. Where you have to put these values? In the values field. In the values field, you have to put these values. Here in the values field. This is the values field. So here in values field, you have to put these values. One for Malay, Chinese, Indian, and others, and this one once again strongly disagree, disagrees, uncertain, agree, and strong. And you will find that this data, when you see the data view, you will find that this data here is like here in gender. You will find that the data has been changed. Okay. Now what you have to do? Now suppose you want to see what exactly is the number for male and what is the number for female. You do not know as of now. So I believe you can see this complete pan of different symbols over here. And you will find that the first one is for open data, second one is for save the document, third one was for print, then recall, redo, and this is undo and redo. And here in the very same pan, you will find that there is a tree-like structure in which A and 1 value labels has been written. This is a toggle button. Once you click it, you will find, you will observe a difference. So what I am doing is I am toggling this button, and what you need to do is you just have to observe the changes in gender, this gender field or the gender variable. Everyone is ready? Okay, here I am starting to toggle this. This is I have toggled it. Seen the change? Observe the change?
Yes, sir.
So this is how you can see the data. Now let us come back for just for an instance. For instance, let us this code this question number 1 as well, and you will find how it looks like. So this is question number 1, variable number 4, question number 1. Let it be question number 1 over here, and then let us go to the values. In values, you will find here it is 1 for strongly disagree. So this is 1 for strongly disagree. Add it 2 for disagree, add it. 3 for uncertain. I please forgive me for any kind of spelling mistakes because I'm typing a little bit faster. Then agree. Here it is, and then no. Here what you have to write down 5, and then you will write strongly agree. Here it is. Okay, and then you will find a change in the data view. Let us go to data view once again. Here is the data view. This is what you can see. Strongly disagree. All are strongly disagree. Question number 1. Variable number 1, 2, 3, 4, 5. No, it was variable number 5, I believe. Okay, let us do one thing. Let us go to the variable view. And what you can do is, since you can see this is already selected, you just have to do is just have to select it. Control C. This is what I am doing over here. And here I am doing Control V in the very next variable number 5, and you will find that it is here. This was actually question number 1, not this one. Now let us see what happens. Here it is. It won't allow you to replicate. Duplicate entries are not at all allowed. So you can write down question number 1 over here. Just a second. Let me have this as ethnicity, and this as question number 1. Or you can have this as variable. You can have this as variable 1. Okay, so this is variable 1, and these are the numbers. Okay, so let us see. Here you will see once again in the data view is variable 1. I can see you people. I hope that you can see here the changes are disagree, disagree, agree, disagree, strongly disagree. No one is strongly agreeing. Once again, I'm going to the toggle button, and you will find the changes. You can observe the changes. Okay, everywhere you can observe the changes. Okay, so this is how we make entries in SPSS. Is it clear to everyone, or should I continue this? Whether I do all the entries, or now it would be easier for you and you will do the rest of the entries. Will it be? So putting it up once again, and let me go to how we already have the data. Okay, so now let us see. I already have the data now, and now once again, depending upon what kind of tests you people are going to perform. So the very first thing I feel that you would be performing would be to know whether the data is normal or not. Normality of the data, that we need to know first. Okay, so how to know the normality, whether the data is normal or not? So I am here. What I am doing is, as of now, I am putting it off, closing this file. Let me use it somewhere else. Okay, and let me show you how we have to check the normality. Here it is. Okay, so data I already have. I have different data sets over here. Some of these data sets on which we are working right now, I shall be sharing all these data sets with you. One thing I believe that you will remember, whenever you are opening a data file, you will see a simultaneous output file is also being opened. You can see a connected output file shall always be open. You can see here it is. This is the data file. This is how it looks like. The data is already here. And now what you want is, you want to see whether what shall be the output. So the output file is different and the input file is different. This Excel looking like file is the input file, and this plain text like so looking file is the output file. You will very soon you will find that here this all which is empty right now, you will find that this shall be like this will be filled with whatever commands you are using, whatever you are doing. So this is like birth weight of a child. So this is the simple a single simple variable. Uh, so the birth weight, and this is the data view. Now what you need to do is you just have to. There are one more thing. SPSS is full of lot of commands, lot of activities. 80-90% of these activities either we do not use, or we use, or we what we do is we already perform all these kind of functions while collecting the data and tabulating the data in Excel only. This is the reason why maximum of the data, most of the commands or most of the options which are shown over here, you will find that we are not even touching those. This is the reason why we are doing this, is because we do not even need it. Okay, so here it is right down on the menu. We shall go to edit, view, data, transform, analyze. Here we have to analyze the data, so we have gone to analyze. Now the first one is analyze, then the first one is reports. This is basically highest, this analyze is the highest used uh, menu, sub menu. So here it is. So reports, you can write down, you can generate different reports from here. As of now, I am not generating any report, but then we have to check whether the data is normal or not. So let us go to descriptive statistics. We have two different options to check whether the data is normal or not. The first one is with the help of frequencies. The second one is with the help of another descriptives. I shall be going to descriptives as of now. Let us go to descriptives, and you will find that a new pop-up has arrived. What you have to do is on the left hand side pan, you will find that different, since it is a single variable, hence a single variable is you can see a single variable. So now just select it and use this variable. So this, we will be using this as variable. So we have shifted it to variable pan. Now what you need to do is you have to go to options. Let us go to options now. And then you have different things over here. What you can do is you can go for mean, standard deviation, minimum, maximum, whatever you want, depending upon whatever you want to write down in your data analysis also. The more you will, the more statistical functions, more statistical tools you are using, the more you will get to write down in your data analysis. So here it is, then variable list. Normality is either being checked by kurtosis or by skewness. So whether the distribution is normal or not, we have to check. Okay, so either by kurtosis or skewness. If somebody can please let me know what are the values of skewness, the maximum and minimum. If somebody can please quickly write it down in the chat box, or even somebody can tell it as well. No, I am not using anything else. So this is, let us continue from here. Style bootstrap, we do not actually require this. Use standardized values as variables. We do not want to use this skewness and kurtosis as variables. So I have not checked it as well. Otherwise, we could have checked it. But this is not, this shall not be used here on. We shall use it later on. So that's why I am not checking it out. Now let us click on OK, and you will find that I have been shifted to the output file. Now you people can see the output. This output is visible to everyone now.
Yes, sir.
Okay. In the output file, you can see here the file is divided into two different pans. The left one is here. You can find the left one. You will find that what exactly is written on the right hand side. At times, when these number of commands or the number of operations are quite good in number, you will find that you can directly just and you want to go to from first of the operation, you have to go to the last of the operation. So you can use this pan, the left hand side pan. Okay, let me do it like this. So here it is, the first one, descriptives over here. Now there could be, like, somebody can also ask that normality can be checked with the help of a graph as well. And what kind of graph that is? If somebody can let me know. While our data, whether our data is normal or not, how we check it with the help of a graph. What is the shape of the graph?
It's a
Which
bell curve, sir. Bell shaped.
exactly, it's a bell shaped curve. However, it has not been made over here. So now once again, what we need to do is we need to check whether the data is normal is or not with the help of skewness and kurtosis. You can see descriptive statistics over here. This is the file. This is actually the command which we are using. What kind of file it is using. That's why this is only informative, nothing else. Then the descriptive, the heading of whatever command we are using, and then here is the location of the file which we have used. This is the output. Okay, this is the output. The table is the output. You can see statistics over here: minimum, maximum, mean, standard deviation statistic. All these things are something which we have ticked over there. There comes skewness. What is the standard value of skewness? If anybody can tell me. Although it is between -1 and +1. I know it is simple as well, and you people know it. But asking again and again a lot of questions will be time consuming as well. So the skewness is +1 and -1. The more it is near to zero, the more normal the data is supposed to be. Here, what the value is, the value of statistic is -0.063. So we can say that the data is normal. Okay. In kurtosis, the value is once again, it should be either +3 or -3. So the statistic is showing once again -0.940. We can say once again, the lower the value, higher will be the normality of data. So since these values are quite low, both these values are quite low, we can say that the data is normal. But now we have to see the bell curve as well. Let us go to check the bell curve now. Once again, let us go to analyze, go to descriptive statistics. Now go to frequencies. We have gone to frequencies. Once again, select the variable, select this as a variable, go to statistics. You will find different statistics over here. I am not actually selecting a lot of statistics over here, except skewness and kurtosis. Nothing else. I am not selecting anything else. You can select anything. Like let us select mean. You could have selected sum. You can have selected standard deviation, median, maximum, minimum, variance, range, standard error, mean. You can select each and everything. So you can select it. Do not worry. You can select whatever you want to see. Now continued. Then let us go to chart. And then here we use histogram. With the help of histogram, we will find whether the data is normal or not. But we have to make a curve. If you leave it like this, it will show you a histogram. But what we want to see is a normal curve on histogram. Here we will click on the square button below histogram. So it will automatically generate the normality curve. Okay. Now continue from here. You do not need to make much changes in this format, style, bootstrap. Just leave it. Display frequency tables. If you want to see the frequency tables once again, you can ask it to. Otherwise, you can leave this unchecked. So I am not asking it to display the frequency tables. Hence, I have kept it unchecked. And once you click OK, you will find that here it is once again informative block, then the frequencies, and then statistics. So here first you can find statistics over here. It has already showing you the valid, missing values, then mean, skewness. The value of skewness is very same, -0.063 -0.063. It resembles. The data is same, hence the value shall always be same. Here is the histogram, the normality curve. I believe you can see this normality curve now. And once again, you can interpret it on the basis of this normality curve as well, that although it looks like a perfect curve, but definitely there are certain values which are more than normal. And that can easily be shown over here as well. I believe you people can interpret this graph now. You are seeing this graph, everybody?
Yes, sir.
Okay. So this is visible to you as well, and now you can curve. Why it is not? Because definitely you can see these towering values. So these values should not be here, but still these values are here. Hence, we can say that this data is not normal. Now, what to do for although this is normal, why? Because it is very much within the limits. The limits are for skewness it is -1 to +1, for kurtosis it is -3 to +3. So hence 9.3. Hence we can say that it is quite normal. What? No, not it should be. What if we want it more to be normal, more closer? We want it closer to 0. What you will do? What you need to do is you need to collect more data. Of course, outliers are there, but what we need to do, we need to collect more and more data. Okay, so the more data you'll be collecting, the normal it will be. You do not even, if you are collecting a data of say 300 or 500 or 700 participants or respondents, you will find that the data is automatically normal. The data in, if you are collecting data for 50 participants, the data may not be a normal. But if you are collecting the data for 500 people, 500 respondents, the data will automatically be normal. This is what you will find. We find almost all type of people, almost all kind of respondents if you are collecting somewhere around 500 or so this, responses. Okay. Now once again, let us do one thing. Here what we have done is we have already checked the okay, infinity error it is showing. Yeah, this is some sort of infinity error also. So just a second. Let me show you now how we have to. I believe that you already remember that Excel file, no? So what you have to do is you just need to. What you need to do is you just have to, just a second. Let me show you that file once again so that we can quickly we can have some tests as well. Now I feel you can see this Excel sheet once again. Everybody can see this Excel sheet
Yes,
now?
sir. Yes, sir. Yes, sir.
It is visible to everybody. Okay. Now let us have, suppose, let us have what we do have different variables. So let us have different kind of say tests from here only. So the very first test which we would be performing on this, like the test, I believe you would be you people already know a little bit about different kinds of tests, parametric test and non-parametric tests. Parametric tests are those tests in which we can calculate the mean, we can calculate standard deviation, we can means there are parameters. In non-parametric tests, these are those kind of tests where you do not have parameters. You do not know anything. The qualitative data is being used. So since quantitative data is used, we shall be using parametric tests. Non-quantitative or qualitative data is collected, we shall be using non-parametric tests. So this is the basic difference. Although there are lots of other differences as well, and we can convert that non-parametric data into parametric data as well. And we can use these tests once again. Parametric tests are supposed to be more reliable as compared to non-parametric tests. Because in non-parametric tests, you have to interpret. What you have to do? You have to interpret the result. However, in parametric test, the result will be very clear. Here you can see the height of a person is 77 inches or 77 centimeters or 128 centimeters or this 100 centimeters, 194 centimeters, 128 centimeters. So this is what exactly it is. This is the height of the person, and if you call what exactly is the height of the person, it is equivalent to 4 hands. It is equivalent to 3 hands. So their reliability is less. However, if you say the height is 128 centimeters, it would be more reliable. So that this is why this is the reason why what we need to do is we need to have more and more quantitative data as compared to that of qualitative. So we shall be, although there are definitely there are methods, there are ways to convert this qualitative data into quantitative data. And once we do that, then we shall be applying this quantitative parametric test on it. The very first test that we generally use to perform is t-test. Okay, and then we do have for the purpose of t-test, what we need to do is we need to have two different variables. The first one among them is definitely a nominal variable, where on the basis of which we shall be bifurcating the data, and the second variable should be the second variable can be the values. It can be a like the nominal. It can be an ordinal value. The first one is nominal, and the second one is, it can be ordinal or it can be anything else. So we are starting with an ordinal value. So let us go through one. Let us do one thing on our Excel. On our Excel, I do not have this Excel as of now. Just a second. Let me do one thing. Let me transfer this data once again to the SPSS. Unfortunately, I have closed it down. So just a second. Let me transfer this data to SPSS once again. It is easier for all of us now to transfer this data into SPSS. Just have to copy it from Excel, and since we already have learned how to change the names of variables and all those things, so that's why I'm not telling you that as of now. I believe you can see the SPSS window. Can you see the SPSS? You can see the Excel only right now. No? Only Excel can be seen. Okay, let us do one thing. Let us do one thing. Just patient's gender. So since this patient's gender is a category, is a nominal variable, let me copy it. So I have copied this variable and I am pasting it to Excel, which I'll show you a little bit later. Okay. The second data which I am collecting from here, since I am showing you only the basic tests, hence I am collecting this second one data, that is patient's ethnicity as well. Let us assume as if it is religious background or so, whatever you want to. But only thing that we should have some more than two variables. So this is the second variable which I have collected, and let us collect the variables from here. Okay. So the height, weight, neck circle, the size of neck, then waist, hip, and blood pressure. So let us collect this complete data and let us transfer it also to SPSS. And now I am showing you the SPSS window. Okay. Let me show you the SPSS window now. And the SPSS window. Where is the SPSS window? Here is the SPSS window. Okay. Now I feel you people can see the SPSS window. Is the SPSS window visible to everyone?
Yes, sir.
Okay. So here is the SPSS window, and this data is completely over here. I am not very much changing the names of the variables as of now, just one or two. So the very first one shall be gender. The second one was ethnicity or religion, you can say. That is, let us make it religion. Then the third one from the Excel itself, it will be height, weight, neck circle. It should be height, weight, neck circle, and waist. Height, weight, neck circle, then waist. Then there comes hip. Then there comes systolic and dilatic BP, or higher higher BP and lower BP. Let us have this. Now you can see our data is here. Now what we have to do? The very first few tests. So since our time, I am extremely sorry that due to certain things. We have started our lecture late, and hence I'm taking a little bit more time from you all people. So please bear with me. So say some 5-7 minutes or more, and in this time we shall be discussing about these two basic tests, t-test and ANOVA, that we shall be applying on this data only. Okay. Will it be okay for all of us?
Yes, sir.
The basic things which I am telling you. Okay, the basic things which I am telling you. I'll try to tell you a little bit about the paired t-test as well. Like do have paired t-test as well. So I'll try to go for paired t-test. Otherwise, we will have this independent sample t-test, and we will have ANOVA, how to use it. Okay. So the very first thing, let us go to once again variables, sorry, data. So the data is gender over here, religion over here, height, weight, neck, then waist, hip, higher BP and lower BP. Okay. So now what we need to do is, let us go for independent sample t-test. Okay. What happens in independent sample t-test is, first we need to have this nominal data. Okay. And the values will be, as I told you earlier, one for male and two for female. Okay. Here it is. So this is it. Not more than that as of now. Okay. Here it is. Now let us go to this data view once again, and you will find that gender over here. That's this, I believe you can see. Now we have this neck as our one of the variables, weight as one of the variables, then waist as one of the variables, hip size is one of the variables. So let us do one thing. Let us have our hypothesis. What should be the hypothesis? The hypothesis, there is no significant difference between the height of male and female. There is no although definitely you would be having a different hypothesis. Those hypotheses will be based on different variables. As of now, we are having, I am just taking an example, that's why I'm telling it. So the height, if you can have like whether a person is working or not, whether the family is dependent upon someone, whose, whether the male or female, whose decision matters more. So we can have these different kind of questions. You will have different answers, and you will be having the very same uh, data. Now let us have this. Whose weight is more? Whose height is more? Whose neck circle is more? Whose waist size is more? Whose hip size is more? Who is more, you can say, more affected by this higher BP? Whose BP is higher, male or female? So what you need to do, you just have to go for t-test. How to go for, wherever there are two different variables. Two different variables means there are two different categories. There are two different nominal variables. There are two different categories, male, female. Okay, like boy, girl, male, female, then member, non-member. So these kind of wherever this kind of data will be there, you will be applying t-test, independent sample t-test. In finance as well. My own thesis was in finance, in banking. So that was like whether you are comparing the data for Indian bank and foreign bank. So these are two different categories. If you are, suppose you are comparing the profits of two different banks, so Indian banks and foreign banks. Okay, so Indian bank will be one and foreign bank will be two. You will be having the second variable as here, like it is height is the one of the variables. You will have profit over. So the profitability of Indian banks versus foreign banks, profitability of Indian private sector banks versus public sector banks. This is how you need to make the hypothesis. I believe that it is clear to everyone. I would be taking not more than 5-7 minutes. Okay, I'm extremely sorry once again for this delay, but please bear with me for 5-7 minutes, and you will feel good definitely. So now here it is. Let us go to analyze. Let us From here, let us go to compare means. The very first analyze, then go to compare means. No, not compare means. Yeah, here it is, compare means. Then we will go to this independent samples t-test. Independent samples t-test. Actually, this is not the size of the window which appears. This has been elongated. This is how it appears actually. So what you have to do, gender. Now gender shall be the grouping variable. We do not have to calculate the grouping. Grouping variable, here you can see this test variable and grouping. Test variable is whatever we want. So suppose if we select all these variables, height, weight, neck, waist, hip, lower BP, higher BP, let all of these be test variables. And let we compare between males and females. So the gender will be grouping variable. Now what you need to do is you have to define the groups. What are your groups? So group 1 will be 1 and group 2 will be 2. You do not need to write down male and female over here. Just have to write down the number or representation. Continue from here. Let us go to options. And we do not actually need to write down anything over here. You just have to, what you need to do, just click OK and you will find the answer on the basis of t-test. Here it is. Here it is. This is the statistics, group statistics. You can see the statistics, male and female, number of males and females, their mean, their standard deviation value, their standard error mean. So the height, the weight, neck rest, that neck circle, waist, hip, higher BP, lower BP. Now let us come to the test. Here it is the independent samples test. So what happens? Height. Let us come to this first, second, third, fourth, fifth. Here you will find DF is the degree of freedom, and this significance value, this is the p value. This is the p value. If you can see in the height row, you will find there are two different sub rows. First one is equal variances assumed, second one is equal variances not assumed. Okay, so you will find that what exactly is the value of this Lebanese test for equality of variances, whether the variances are equal or not. So you will find that this significant value. I believe that you people know what the rule of thumb for accepting or rejecting the p-value, accepting or rejecting the hypothesis. Anybody can tell me? If anybody can please tell me what is the thumb rule for accepting or rejecting the hypothesis? The value should, if the value is less than 0.05, what do?
0.05, it's so if
We
the
shall
p
reject.
value
We shall reject the hypothesis. If the
Yes.
p value is less than 0.05, we shall
Reject.
reject the hypothesis. So our first hypothesis, what is our first hypothesis? Your first hypothesis will be that the variances are equal or not. Okay, so the variances are equal. It means when you make a null hypothesis, the hypothesis will be there is no significant difference in the variances of heights, in the variances of height between male and female. Okay. Why I am telling you this is because we are having two different set of values. You can see this upper row and this lower row. You can see this everywhere in height, weight, neck, waist, hip, each and everywhere. You can see there are two different rows in each row. In each major row, you will find there are two sub rows. And why these sub rows are? Because we have two different assumptions, equal variances and equal variances not assumed. So which we have to collect, which we have to select. This will be dependent upon the very first two columns, Leibniz test for equality of variances. So let us assume as if the variances are equal. If the value is less than 0.05, it means the value, if it means that the variances are not equal. So you will calculate, pick which values will you assume, or which values you need to consider, the lower row values. And if the value of this significance, first f and then significance, if this value is more than 0.05, you have to select the upper row. Okay, so this is equal variance as assumed and not assumed. So since this value is 0.766, it is more than 0.05, we shall assume as if the variances are equal, and this upper row we shall be considering this significance, two-tailed significance. I believe you can see I'm circling this two-tailed significance. I believe you can see this 0.879. So our first hypothesis, there is no significant difference between the height of males and females, stands accepted. There is no significant difference between the height of males and females, stands accepted, as the p-value is more than 0.05. Is it clear to everyone? Thank you. Similarly, weight, similarly for next circle, you will find that these values everywhere, these values are more than 0.05. So what we need to do, we need to accept all these hypotheses that there is no significant difference between in the height and height, weight, neck circle, waist, hip, higher BP and lower BP of males and females. This is what we have to accept. So our null hypothesis will be accepted over here. This is how we use t-test. Okay. Second one, what I am using is ANOVA. Okay. Is this test clear to everyone? This is independent sample t-test. Is it clear to everyone?
Yes, sir.
Okay, thank you. Let us, in a quick fashion, let us go to ANOVA. So once again, let us go to analyze. Once again, go to compare means, and you will find on the very last row, you will find one way ANOVA. Can you see this? Now for ANOVA, we need to have more than two categories. I am selecting it. What we need to do? We need to have more than two categories. We need to have more than two groups. In religion, in gender, we have two groups only. In religion, we have more than two groups. Okay, just a second. Here I can see a little bit error. This higher BP is in nominal form. We have to change it. Let us get quickly back to the variable view in our data file and change this nominal to scale only. Okay. Now let us get back to our output file. And can anybody tell me what exactly you are seeing on the screen? It is data file or the output file? Anybody?
Data file, sir.
Data file only. Okay. Let me show you the output file. Or it would be better if I start showing you the complete screen. That would be easier for you. Entire screen. Here it is. Now you will be able to see entire screen once again. So this is the output file. This is the output file. Whether this output file was visible earlier as well, when I was discussing a little bit about this t-test. It was not visible. Just a second. In a very quick manner, I am once again doing this t-test. Okay, please look at it carefully. Here it is. To analyze this, analyze menu. Then we'll go to compare means we'll go to independent sample t-test. You will find over here all these variables are test variables. Earlier these variables were like this. They were appearing like this. So what we'll do, we will This gender was once again not here. So this is how it was appearing initially. We shall be, these are our test variables like height, weight, neck, waist, hip, lower BP, higher BP. These are our test variables. Here we have done it. Then this gender is our grouping variable. So we will make it as a group. You need to define the groups. Here we have defined the groups as 1 and 2. We'll continue from here. Go to options. Do not do any change. Whatever written over here is perfectly fine. You do not have to do anything. You just have to click on OK. Here you have clicked on OK. You have got this group statistics. You have got this independent sample t-test. This is once again Lebanese test for equality of variances. As we were discussing, I was telling you earlier, the significance value is less than 0.05. In that case, you will have to assume as if the variances are not equal variances not assumed, and hence is the height, this row having this the values of height, it is having two different sub rows, it is having two different subsets of data, subsets of information, the upper subset and the lower subset. The upper subset is for equal variances assumed and the lower subset is for equal variances not assumed. Since the very first value, this Lebanese test of equality of variances is more than 0.05, we will assume as if the variances are equal. So the variances are equal, hence we will be using this upper subset of the data and not the lower subset of the data. So upper subset of data used to say the significance value, the p value of this test is 0.879. It is more than 0.05. Hence our first hypothesis, there is no significant difference in the height of males and females, stands accepted. Is it clear to everyone? The
Yes, sir.
second hypothesis, there is no significant difference in the weight of males and females. Once again, the significance value, you can see it is 0.941, which is once again more than 0.05. Hence, once again, the null hypothesis, there is no significant difference between the weight of male and female participants, respondents, stands accepted. This significance value, when it drops to less than 0.05, you will find your hypothesis will not be accepted. Okay. Now quickly, once again, I am going and I am showing you how to use ANOVA. Okay. Once again, go to analyze, go to compare means, and here it is one-way ANOVA. I believe everybody can see this interface, one-way ANOVA. Now, one-way ANOVA, as I told you, the ANOVA, for ANOVA, you have to have more than one subgroup. You have to have more than two subgroups. Even if you are using ANOVA and you will be applying ANOVA on gender, you will find that the answer will be very same. Because even if ANOVA itself, it is a part of t-test only. It is an advanced t-test, you can say. So what we need to do, we have to select something which is more than two. As I told you that while going for the financial research, what I did earlier was, like in banking, I was having two different banks, Indian banks and foreign banks. So I was having nationalized banks and private banks. I was having private sector banks, public sector banks. There you will be applying t-test. But wherever the number increases, like if we talk about overall banking in India, you will find you will have private banks, public sector banks, and foreign banks. So the number of groups increased from 2 to 3. We shall be using ANOVA. So this religion is a factor, and dependent variable will be height, weight, neck, waist, higher BP, lower BP. Once again, this will be dependent list, and this religion will be the factor on the basis of which we are distributing or we shall be comparing. So the contrast, you need not to do anything. Do not need to write anything over here, coefficients or whatever it is. Post hoc, as of now, I am not telling you much about post hoc test. Otherwise, we can have post hoc analysis as well. Post hoc analysis is something where these three variables are being compared as if there are two variables. So you will